This video is on mole conversions. You should have your periodic table out for this, and you also should have watched the molar mass video that was previous to this one. So you learned that 1 mole, remember, it's just a quantity, so it's the number of particles, and those particles can be atoms, they can be ions, they can be formula units or molecules. But there are 6.02 times 10 to the 23rd of these things, whatever they may be, in 1 mole. Just like there's 12 of any particle in a dozen. So this is also equal to the molar mass of an element or compound in grams. And remember, this molar mass, that's what the previous video is about, that's from your periodic table. So that's what we practiced previously. Then the mole, one other thing, is that it's equal to 22.7 liters. So now we're talking volume of any gas at what we call standard temperature and pressure. For right now, you don't need to really know what standard temperature and pressure is. Just know that that's the only time this is true, and we will talk about later when that's not true what we do. So we use these as conversion factors. So we can use them to convert from different units to each other, and we've got a little map here, and you have it in your notes packet that can help with this. So everything you can see relates to the mole. So depending on whether you're talking about grams, which is actually mass, I'm going to write that in here, or you're talking about liters, remember, only of a gas at STP, which is volume, or you're talking about particles, we can convert any of those to moles, which we could then convert to another unit. So I'm going to do a few examples with you. Follow along, write everything down, and make note of any questions you might have. So in this first one, we're converting 45.7 grams of H2O to moles. So we're starting with grams. So we're starting at this point, and we're going to this point. So we're doing this path right here. So we can do this in one step. So I always start with, like with any conversion, by writing my given value, 45.7. Remember, I need units, and I'm going to write what it is, grams of H2O. So when I'm doing a conversion, I set up my fraction. I'm multiplying by a fraction. That top and bottom are those conversion factors we were looking at over here, these right here. Okay, so for this one, I want grams to cancel. I want them to divide out. So I always start with units on the bottom for this, because grams on top and grams on the bottom will divide out. And if you want to write this over 1, by the way, you can, but it's not necessary. So what are my grams pointing to? My arrow is pointing to moles, which means I can then convert grams to moles of this same substance. So moles is always going to be 1, and the grams is that molar mass. And if you remember, that's from your periodic table. That's what we calculated before. So if I do the math quickly, and normally you would not have to write this out for a problem like this. So I have H, and I have 2 of them, times the mass of each one, which is 1.01. So 2.02 is my mass of hydrogen. And my oxygen, there's only 1 oxygen in water, times its mass of 16.00. So when I add these together, the total mass is 18.02. And that's the number of grams in that 1 mole. So that top and bottom, those values equal each other. So now I can see that my grams of water divide out. So my only unit, notice numbers didn't divide out. My only unit left is moles of water, which is what I'm trying to find. So here's where I can go to my calculator and type this in. Now, you can type in the 45.7 times 1 divided by 18.02, but you should know that multiplying by 1 doesn't change anything. So you can just type in 45.7 divided by 18.02. Now, this will give you 2.54, and the reason I'm going to round it there is because this value, my starting one, has 3 significant digits, so my ending one should have the same. We don't use conversion factors for significant digits. So I get 2.54. I need units, moles, and substance, H2O. So there's my answer. So let's do another example. If at any time you feel like you want to try these on your own, pause the video, try it, and then watch and see how you did. So the next one, I've got 87.3 moles of CO2 to molecules. So I'm going from here to molecules as a particle to here. So I'm doing this right here. So again, I can do this in one step. So 8.73 moles of CO2. If you want to put that over 1, you can. All right, and I set up my conversion factor. So I want moles to divide out, so I'm going to put that on the bottom. Whatever I'm getting rid of has to be opposite. Whatever I'm switching to, molecules in this case, is going to be on top. And sadly, there is no abbreviation for molecules, so we do have to write that out. So all of these relate to 1 mole. So the question is how many molecules? If you go back to here in your notes, that's that 6.02 times 10 to the 23rd, Avogadro's number. Okay, so I can see then that moles of CO2 cancel out. Now when I type this one in my calculator, I want to be really careful because I'm going to multiply that 8.73 times the 6.02 times 10 to the 23rd. But there is a really much better way to type this in your calculator with scientific notation. And if you don't do it correctly on some calculators, it will give you the wrong answer. You're going to look for a button on your calculator that's probably this. Most Texas Instruments have this button. Casio usually has this one. And some Texas Instruments will have a times 10 to the n. Okay, but this is the most common. So that button replaces the times 10 to the power of. So if I wanted to type in the 6.02 times 10 to the 23rd, I would do 6.02, whatever your button is. On my calculator, it's this one, and then my exponent. I didn't hit times, I didn't hit 10, I didn't hit the power of. So practice typing that in because you should get 5.26 with 3 sig digs, because this is 3, times 10 to the 24th. Don't miss that scientific notation all the way to the right. Now my units are molecules, and my substance is CO2. Okay, let's do another one. Oops, too far. Okay, so let's do something with liters now. So I have 4.923 liters of O2. It says it's a gas at STP, so we can use this. I'm going from here to moles. So we're doing this right here. So we're going to end up here. So I want liters of O2 to divide out. So bottom, opposite, moles of O2 is what I want to calculate. And in 1 mole of O2, there are 22.7 liters. So my liters of O2 divide out. When I type this in, it's going to be that 4.923 divided by 22.7. So here I get 0.2169 because I have 4 sig digs to start. I have 4 to end. And this is moles of O2. So there's an example of each kind of direction, going from one spot to every other spot. But let's do one more problem, because in this problem, we're converting 0.95 grams, so right here, of sodium to atoms, so right here. So we're going to go this as our first step, step 1, and this as our second step. We have to do this in 2 steps. So we're going to go from grams to moles, and then moles to atoms. And we're going to do this all in one problem because it is simpler. You will do less work and you're less likely to make a mistake. So just like the other ones, point. Okay, so I write 0.95 grams Na. And I first set this up to cancel my grams of sodium and convert to moles. Now notice I always write my units before I do my numbers. I want to make sure I have those in the right place before I put any numbers in. So for moles, it's always 1. But my grams, remember, is my periodic table. So I look up sodium. Since it's just the one thing, I don't have to add anything to it. So 22.99. And at this point, my grams of sodium, oh, that was weird. My grams of sodium have canceled. But I'm not done with my problem because I have moles, though I want atoms. So that's where I just try another conversion factor. Now I have moles, so let's cancel those by putting them on the bottom. And to go to atoms, put that on top. All right, so everything is related to 1 mole, but my atoms, that's that particle, is that 6.02 times 10 to the 23rd. So I know I'm ready for my calculator because everything is divided out unit-wise except my atoms, which is my unknown. So now when I type this one in, be careful. You could do this a couple different ways. You could do the 0.95 first. So I'll write it up here, 0.95, and then you could multiply by 6.02. We could just go across the top. Times 10 to the 23rd. Don't forget this is that scientific notation button. And then I could do divided by 22.99. Now the other way to do that is instead of just doing across the top first and then divided by anything on the bottom, is I could just go like a section at a time, like 0.95, and the next section I would divide by 22.99, and then the next section I multiply by 6.02 times 10 to the 23rd. Both of those you will get the same answer because in the order of operations, multiplying and dividing are the same. So type this in just to make sure that you are getting 2.5 times 10 to the 22nd atoms of sodium. So this is a skill you want to be very comfortable with, which is why we're going to practice it quite a bit. Make sure you talk to me if you have questions on this or you need help or you aren't getting the right number in your calculator with scientific notation especially. You don't want to get it wrong just because you didn't know how to type it in your calculator.